मेरा नाम दिलीप तनेजा है. I am the CEO of Ace Automation Traders, and today I'm going to talk about centralized oil lubrication COLs for short. I've been associated with the manufacturing, design, installation of COLs for 23 years now, and over the years I have also analyzed failures and a total of 509 failures I have studied, and these are across industries: paper, sugar, steel, cement, power. And मुझे बहुत it's really surprising to me that lakhs and crores of rupees of profits is being lost, and the business owners, the CFOs, the CEOs aren't even aware of it. And second thing is that they're easily preventable, and we can all increase our profits by doing simple, taking care of simple things like having a good fuel system or attending to the problems of the one that has been installed. And to explain this further, I am first going to talk about what essentially is the purpose of a centralized oil lubrication system, and then go on to the problems and what they are doing to your industry and how we can resolve them. So the primary function of a centralized oil lubrication system, as the name suggests, is to supply filtered, clean, cool oil to the bearings or the bushes or the gears or the any rotating part, rotating machinery, so that it moves, it is lubricated well. The primary purpose of providing this lubricant, of course, is that it should be lubricated, the bearing should be lubricated. Second, the oil removes the heat that has been, the frictional heat that has been generating, that gets generated in the rotating element. And third, during the movement of the rotating element, some debris, some wear and tear of the material takes place. So the oil also helps to flush that and take it back into the tank. Now, the types of failures. There are two primary types of failures. One could be the failure of the bearing itself, bearing or the bush, causing it to seize, in which case you have to bear the cost of an unscheduled shutdown, resulting in loss in productivity. And secondly, the cost of the maintenance, of the replacement of the part of the bearing, and the maintenance cost of the same. So this is one type of failure. The second type of failure is even more dangerous. I like to call it the silent killer. Why do I call it the silent killer? Because it kills our profits silently over the years, weeks, months, years, and we never even come to know about it. When the bearing or the bush has got damaged, but it is not completely broken, what happens is that the amount of power required to rotate the machinery part starts increasing. As a result, the drive power gets the power drawn by the electrical motor or the engine, that increases, and it's obviously costing us money, and you can understand this more if better if you look at it from the perspective of a rolling mill where there are many bearings and bushes, and if each of them starts drawing a little more power, then you can imagine what is happening to the main drive motor, the amount of power that the drive motor is going to increase and is costing us, the power is costing us on a daily basis, on a weekly basis, on a monthly basis. So, to prevent this, I have I'm going to talk about prevention. For prevention, there are two aspects to the prevention. One is the lubrication system, which typically would look something like this, and two is the piping that carries piping and instrumentation that carries oil from here to the bearing and back to this reservoir. So why do the failures take place? Because the oil has stopped coming into the bearing, or the adequate amount of oil has stopped coming into the bearing. Typically, this could be because my pump has failed, right? So to prevent this, we plan a system which has two motor and pump assemblies and a control panel which ensures that the moment one pump fails, the second one automatically comes on. As a result, we will never have dry pipeline. Oil will always be flowing. The second reason for the stop of oil flow is that perhaps due to a leak in the pipeline or anywhere in the system, the oil level is dropping and eventually the pumps start running dry. So if we fix in the tank a level switch which with two switching points, the first one will give us an alarm the moment uh, some oil starts leaking and the level of oil in the tank is dropping, so that the preventive maintenance can be done and we plug that hole and add top up the oil. In case this is not rectified, the oil level will keep falling down, and at the second level, before the pump actually runs dry and there is no fluid flowing through the pipeline, we are able to shut down and stop the failure from taking place. Other reasons for failure are, like I said, there were three main objectives of a centralized oil lubrication system. One is to, of course, lubricate. We've talked about, we've taken care of that aspect of it. Second is to cool it. Not cool it, we need to supply cooled lubricating oil. That can be achieved through an adequately sized heat exchanger. So where the pump is sucking oil from the tank and it is getting cooled in the heat exchanger and then getting pumped into the system. The heat exchanger can be air cooled or water cooled. The advantages of water cooled system, especially in, let's say, an environment where of paper mill where water is available in abundance. The positives are obvious, but the negatives are not so obvious, meaning that most of the industry runs on hard water, and over a period of time, the pipes inside the heat exchanger, they get scaled. As a result, the heat exchange between the water and the oil stops. So either we can overcome this by setting up a schedule of monitoring and timely descaling of the heat exchanger. Alternatively, we can use an air-cooled oil cooler. An air-cooled oil cooler essentially requires only the ambient air to cool the oil, and as such does not require too much maintenance. The third aspect is that as the bearing moves or the bush moves, some wear and tear takes place, and metal particles, could be non-metallic particles also, get released, and the oil carries, flushes these and brings them back into the tank. Now, a good lubrication system has to ensure that when the oil is sucked again from here to be pumped, it should be filtered by an efficient filter. When I say efficient, I am putting stress on the word efficient because filters filtration, like any engineering process, has an efficiency. So if I have a filter but it is inefficient, I assume that it is going to filter all the particles or most of the particles, but if it lets through some of the filter, some of the oil unfiltered, or is not able to remove the contaminants, then those contaminants are going to go back into that bearing and act as an abrasive and will actually speed up the wear and tear process. So the filter used has to be very efficient. Also, over a period of time, the filter will get clogged. So we must have an alarm to indicate to us that the filter is about to get choked, and also we must have ensured that there is a standby filter. So the moment there is an alarm, we switch over to the second filter, and in the first filter we change the filter element and keep it ready for a situation when the second filter gets choked. This process need not be automatic because we can get some time between we come to know that the filter is about to get choked a little bit before it actually gets choked. So automation may help in this thing. So just taking care of these three primary issues. One, we have a filter. We have a standby pump and an auto changeover system where when the moment the one pump fills, we switch to the second pump. Second, a good and efficient lubrication oil cooling system. And third, two filters, one working, one standby, and an alarm system to tell us when the filter is going to get choked. So I'm done with explaining about what we need to do with the lubrication system. The second part of the challenge is the piping. So this is my lubrication systems. I have taken the example of a paper mill, but the sign is going to pump the blue. The red line represents the pumping line. The oil from the pump is going in this red line and getting distributed all across. It's going, getting distributed in different bearings, and from the bearing it comes back by gravity and comes back into the tank. Most of the cases, the fuel system is placed below the ground level so that the oil efficiently flows down. Now, what we have to ensure is that each bearing gets the required amount of oil. In the older days, we had this kind of a contraption with which the oil from the pump was coming here, and these are the distribution lines going to the bearing. We could see the oil here, and we could set using these knobs or sometimes even a screw. But the problem with this system is that I don't know how much oil is going into each bearing. I know that oil is going, I can see oil here, but how much is going I cannot control. A level up on this is a system like this. This is a unit for two bearings. The main pump line comes here, and the oil gets distributed to two different bearings. I can set the amount of oil that is going to each bearing, and I can also see on the scale the float moves up, and I can see on the scale the amount of oil that is going into each bearing. And for even more critical systems, what we can do is add in this outline, we add a simple flow switch, which can give us a trigger in case the oil flow stops, oil flow going through the bearing stops, we get an alarm on our panel that this particular bearing is not getting enough oil, and it can be attended to. In cases where it's really critical, then we can even fit a temperature probe in the bearing housing. And of course, this even though the probe is not really an expensive proposition, but if we have too many of these, carrying all these wires right till the control panel and monitoring each temperature of each bearing can be a bit of a daunting task. So it may not really be required or necessary for most applications. I would only suggest it in very critical applications. Another point that we need to understand and take care of in the piping is that the oil going into the bearing is coming from the pump, it's under pressure, so it will automatically go. This is the distribution unit that I talked about. We can use this to regulate the amount of fluid going into this bearing and this bearing. The problem is that the oil that after doing its job of lubrication and cooling and flushing the particles, it's going to come out through this blue tank line and back into the tank. One of the main problems that I have noticed is that there is no air vent line provided. As a result, many times there is an airlock and this oil stops going out and the bearing will start overflowing. And the first reaction that a maintenance guy does is goes and switches off the COL system to prevent this oil from leaking. But that is where the problem actually starts. So this air vent for each bearing is really crucial. I hope I was able to explain to you the issues involved with the centralized oil lubrication system, and let's move together and start saving money for our respective organizations. And I can't even, if each unit starts saving money, think of what we're talking about on a national level in terms of not only increasing our profits, but also the production that is going to increase because of less downtime that we are going to have. So thank you for watching this video, and if you have any questions, feel free to write to me. My name once again is Vineet Taneja, and my email ID is vineet@acefluidpower.com. That's VINEET @ACEFluidPOWER. Thank you once again. Bye bye.